In this video, we are going to solve some questions under binomial expansion. Write down the first four terms of the binomial expansion of into bracket 2 plus x over 4 exponent 10 in ascending powers of x. And then the second part says that use your expansion in I to find the value of 2.025 exponent 10, correct to the nearest whole number. So the expansion is into bracket 2 plus x over 4 exponent 10. So starting, so this is equal to, now, so that the first term will be 10 combination 0, then 2 exponent 10, then x over 4 exponent 0. Then the second term, so plus 10 combination 1, 2 exponent 10 minus 1 is 9, then x over 4 exponent 1, then plus the next term, which is 10 combination 2, 2 exponent 10 minus 2 is 8, then x times x over 4 exponent 2, then this is 1, 2, 3, then the last term, which is 10 combination 3, 2 exponent 7, then x over 4 exponent 3. So 10 combination 1 times 2 exponent 10, x over 4 exponent 0 is 1. So if you compute that, you get 1024. Then plus 10 combination 1 times 2 exponent 9 times 1 over 4 times x will give 5,120 times x over 4, then plus this term, which is 10 combination 2 times 2 exponent 8, and that will give 11,520, then times x squared divided by 4 squared is 16, then plus 10 combination 3 times 2 exponent 7 is equal to 15,360, then x exponent 3, so times x exponent 3 divided by 4 cube is 64. So if we simplify further, we are going to get 1024, then plus 5,120 divided by 4 equals 1,280x, then plus 11,520 divided by 16 times x squared is equal to 720x squared, then plus this term is 15,360 divided by 64, here's x cubed, so it's equal to 240 x cubed. So this is the four terms of the expansion. Now, the second part of the question says that we should use it to evaluate 2.025 exponent 10. Now, we can write that as it is 2.025 exponent 10. So this is the same as 2 plus 0.025 exponent 10. So what it means is that this 2 is this one, then x over 4 is equal to 0.025. So this implies that x over 4 is equal to 0.025. So if we multiply through by 4, then x is equal to 0.1. So what it means is that we are going to put 0.1 into this expansion and then find the value of 2.025 exponent 10. So remember that we have already established that the expansion of into bracket 2 plus x over 4 exponent 10 is equal to 1024 plus 1280x plus 720x squared plus 240x cubed. And then 2 into bracket 2.025 exponent 10 would then be equal to, but we have already established that x is equal to 0.1. So we are putting 0.1 into this equation. So this becomes 1024 plus 1280 times 0.1, then plus 720 times 0.1 squared, then plus 240 times 0.1 cubed. So this is equal to 1024 plus 1280 times 0.1 is equal to 128, and plus 720 plus times 0.1 squared is equal to 7.2. Then 240 times 0.1 cube is equal to 0.24. So if we add all, we are going to get 1159.44. But from the question said we should leave it correct to the nearest whole number. So in writing this correct to the nearest whole number, the correct answer is 1159. Write down the binomial expansion of into bracket x plus 2y exponent 5. And the second part is use your expansion in I to evaluate into bracket 1.02 exponent 5 correct to 3 decimal places. X plus 2y exponent 5 is equal to 5 combination 0 x exponent 5 then times 2y exponent 0 plus 5 combination 1 x exponent 4 times 2y exponent 1 then plus 5 combination 2 x exponent 3 then 2y exponent 2 then plus 5 combination 3 x exponent 2 then times 2y exponent 3 then plus 5 combination 4 x times 2y exponent 4 and plus the last one, which is 5 combination 5 x exponent 0 times 2y exponent 5. So if we simplify this further, 5 combination 0 times x exponent 5 times 2y exponent 0 is equal to x exponent 5 plus 5 combination 1 times x exponent 4 times 2y exponent 1 is equal to 10 x exponent 4y, then plus 5 combination 2 times x exponent 3 times 2y exponent 2 equals 40 x exponent 3 y exponent 2, then plus 5 combination 3 x exponent 2 times into bracket 2y exponent 3 equals 80x squared y cubed, then plus 5 combination 4 times x times into bracket 2y exponent 4 equals 80x y exponent 4, then plus 5 combination 5 times x exponent 0 times 2y exponent 5 equals 32 y exponent 5. Now, the second part of the question says that we should use this expansion to evaluate into bracket 1.02 exponent 5. But we can rewrite that as 1 plus 0.02 exponent 5. So this implies that x is equal to 1 and then 2y is equal to this value, which is 0.01. So dividing through by 2, you get y equals, sorry, here is 0.02. So you get y equals 0.01. So that means that we are going to put x equals 1 and then y equals 0.01 into this equation to evaluate this. So this is equal to 1 exponent 5 plus 10 times 1 exponent 4 times y, which is 0.01, then plus 40 times 1 exponent 3, then y, which is 0.01 exponent 2, then plus 80 times 1 exponent 2, then y, which is 0.01 exponent 3, then plus 80 times x, which is 1, times 0.01 exponent 4, then plus 32 times 0.01 exponent 5. 1 exponent 5 is 1, plus 10 times 1 exponent 4 times 0.01 is 0.1, then plus 40 times 1 cube times 0.01 square equals 0.004, then plus 80 times 1 square times 0.01 cube equals 0.00008, then plus this thing, which is 80 times 1 times 0.01 exponent 4 equals 0.0000008, then plus 32 times 0.01 exponent 5 equals 0.000000032. So if we add all, we are going to get this is equal to 1.104080803. However, the question says that we should write it correct to 3 decimal places. So in terms of 3 decimal places, it's going to be 1.104. What if we are given into bracket 1 plus x exponent n to expand to the nth term? So this is equal to n combination 0, then times 1 exponent n, then times x exponent 0. So that's the first term, plus n combination 1 times 1 exponent n minus 1, then times x exponent 1. Then the next term is n combination 2 times 1 exponent n minus 2, then times x exponent 2, then plus the next term is n combination 3 times 1 exponent n minus 3, then times x exponent 3. Then so now in simplifying further, n combination 0 is the same as n factorial divided by n minus 0 factorial, then times 0 factorial. Then 1 exponent n is 1 times x exponent 0 is also 1. Then plus n combination 1 is the same as n factorial divided by n minus 1 factorial, then 1 factorial, times 1 exponent n minus 1 is the same as 1, then x exponent 1, so times x exponent 1, then plus n combination 2 is the same as n factorial divided by n minus 2 factorial, 2 factorial, then 1 exponent n minus 2 is the same as 1 times x exponent 2. So here's x exponent 2. Then plus n combination 3 is the same as n factorial divided by n minus 3 factorial, 3 factorial. Then 1 exponent n minus 3 is 1 times x exponent 3. So yes, x exponent 3 plus. So it keeps going in that fashion. Now, let's further simplify this. So this is n factorial divided by n minus 0 is n. Then 0 factorial is 1. So it becomes n factorial times 1. So divided by n factorial here. And plus n factorial can be written as n times n minus 1 factorial divided by n minus 1 factorial, then 1 factorial, plus n factorial can also be written as n times n minus 1 times n minus 2 factorial divided by n minus 2 factorial and 2 factorial and plus. This can also be written as n times n minus 1 times n minus 2 times n minus 3 factorial, all divided by n minus 3 factorial 3 factorial. Sorry, I forgot to add the terms. So here is x exponent 1, here is x exponent 2, then here is x exponent 3. Then it keeps going in that fashion. Now, so n factorial divided by n factorial is 1 plus this n minus 1 factorial cancel n minus 1 factorial. So here becomes n x exponent 1 divided by 1 factorial plus n minus 2 factorial, n minus 2 factorial will cancel out. So here becomes n times n minus 1 divided by 2 factorial, then x exponent 2, n plus n minus 3 factorial, n minus 3 factorial will cancel out. So we are left with n times n minus 1, then n minus 2, all divided by 3 factorial, then x exponent 3, then it keeps going in that fashion. So at the end of the day, you can see that we are beginning to see a certain pattern. The pattern is that anytime we are given 1 plus a certain variable exponent n, then the first term is 1, then plus n times then x exponent 1 divided by the power factorial. So here, the third term is n times n minus 1 x squared divided by 2 factorial. Then the third term is n times n minus 1 n minus 2 x exponent 3 divided by 3 factorial. So we are going to use this concept to solve many other examples. Write down the first 3 terms of the binomial expansion of into bracket 1 plus ax exponent n in ascending powers of x. If the coefficient of x and x squared are 2 and 3 over 2 respectively, find the values of n. So the binomial expression is 1 plus ax exponent n. So the first term is 1, and the second term is n times ax exponent 1 divided by 1 factorial. Then the third term is n times n minus 1 times ax exponent 2 divided by 2 factorial. So we are only looking for what? The first 3 terms. So these are the first 3 terms. However, if we simplify further, this becomes 1 plus nax, because 1 factorial is the same as 1, then plus n times n minus 1, then times a squared x squared divided by 2 factorial is the same as 2. However, the question says that the coefficient of x is 2. So it implies that na is equal to 2. So this is equation 1. And then the coefficient of x squared is 3 over 2. So this is the coefficient of x squared, which is n times n minus 1 times a squared divided by 2. And it is equal to 3 divided by 2. So if we multiply through by 2 and multiply here 2 by 2, and this will cancel, and this one too will cancel. So at the end of the day, n times n minus 1 a squared is equal to 3. So this becomes our equation 2. So from equation 1, we can make a the subject. A is equal to 2 over n, and that is equation 3. And then we can then put the equation 3 into equation 2. So this becomes n times n minus 1. Then a squared becomes times 2 over n squared equals 3. So n times n minus 1, then times 2 squared is 4 divided by n squared equals 3. So let's expand. So this becomes n squared times minus n, then times 4 divided by n squared equals 3. So if we multiply through, this becomes 4n squared divided by n squared, then minus 4n divided by n squared equals 3. So this becomes 4 minus 4 divided by n equals 3. So let's multiply through by n. So it becomes 4n minus 4 is equal to 3n. So making n the subject, if we bring 3 here, it becomes n is equal to 4. Now that we have n equals 4, then we can substitute it into equation 3 to find the value of a. Because we know that a is equal to 2 over n. So a is equal to 2 over 4. And therefore a is equal to 1 over 2. So the value of n is 4 and the value of a is 1 over 2. Write down the ascending powers of x, the first 4 terms of the expansion of, into brackets, 1 plus 0.5 x exponent 6. Using your expansion value correct to 4 decimal places, into bracket 1.02 exponent 6. So the binomial expansion expression is 1 plus 0.5 x exponent 6. So this is equal to, the first term is 1, then plus the second term, which is 6 times 0.5 x exponent 1 divided by 1 factorial, then plus 6 times 5, then times 0.5 x exponent 2 divided by 2 factorial. So this is the first term, second term, third term. But we are looking at the first 4 terms, so we need to add the last term, which is 6 times 5 times 4, then times 0.5 exponent 3 divided by 3 factorial. Now, this is equal to 1 plus 6 times 0.5 is equal to 3. So here is 3x, then plus 6 times 5 times 0.5 squared divided by 2 factorial is 3.75 x squared, then plus 6 times 5 times 4 times 0.5, there's an x here, adding it, exponent 3 divided by 3 factorial is 2.5 x exponent 3. Then the second part of the question says we should evaluate 1.02 exponent 6. This can be written as 1 plus 0.02 exponent 6. So it implies that 0.5x is equal to 0.022. So dividing through by 0.5 and divide here to by 0.5, it implies that x is equal to 0.04. So we are going to insert 0.04 into this expression. So this is equal to 1 plus 3 times 0.04, then plus 3.75 times 0.04 squared, and plus 2.5 times 0.04 cube. So this is equal to 1 plus 3 times 0.04 is 0.12 plus 3.75 times 0.04 squared equals 0.006 plus 2.5 times 0.04 cube equals 0.00016. So if we add all, we are going to get 1.12616. But the question says we should write it correct to 4 decimal places. So this is approximately 1.1262. Write down the binomial expansion of, into bracket, 1 plus x exponent 4. And then B, use the result in A to evaluate, into bracket, 5 over 4 exponent 4 correct to 3 decimal places. So the expression is 1 plus x exponent 4. So the first term is 1 plus the second term, which is 4 times x exponent 1 divided by 1 factorial plus the third term is 4 times 3 times x exponent 2 divided by 2 factorial. And then the next term is 4 times 3 times 2 then times x exponent 3 divided by 3 factorial. And the last term is 4 times 3 times 2 times 1 times x exponent 4 divided by 4 factorial. So this is equal to 1, then plus 4 times x is 4x, then plus 4 times 3 divided by 2 equals 4 times x squared. Sorry, equals 6 times x squared becomes 6x squared, then plus this 3 factorial is 6, 3 times 2 is 6, so here becomes 4 times x exponent 3, which becomes 4x exponent 3, then plus this is the same as 4 factorial. So 4 times 3 times 2 times 1 divided by 4 factorial is 1 times x exponent 4 will give us exponent 4. So this is the expansion. Now we are supposed to evaluate 5 over 4 exponent 4. Now we need to be able to write it in terms of 1 plus a certain value. Now 5 can be written as 4 plus 1 divided by 4, all exponent 4. And so this can be written as 4 divided by 4 plus 1 divided by 4 exponent 4. And 4 divided by 4 is 1. So this is equal to 1 plus 1 divided by 4 is 0.25 exponent 4. So this implies that x is equal to 0.25. So we are going to insert 0.25 into this expression. So it becomes 1 plus 4 times 0.25, then plus 6 times 0.25 squared, then plus 4 times 0.25 cubed, then plus 0.25 exponent 4. So this is equal to 1 plus 4 times 0.25 equals 1 plus 6 times 0.25 squared equals 0.375, then plus 4 times 0.25 cubed equals 0.0625, then plus 0.25 exponent 4 equals 0.00390625. So if you add all, we are going to get 2.44140625. But the question says we should leave it equal to 3 decimal places. So this is approximately 2.441.